Everybody. On behalf of the
Yeah, good
coordinator,
evening, madam.
uh, all the participants, please listen. Uh, our speaker is already ready. He is P. Rajesh Kumar. Now he is working as the Dean in Academics in NIST University. He has professional life with cumulative 25 years in the field of academic. As a professor, he has made significant contribution to the domain of VLSI, design and robotics. He has done his PhD from IIT Madras. He has actively involved in teaching as well as research. His expertise is reflected by showcasing the involvement in the cutting-edge research. His publications include the work in the medical image fusion using the convolution neural network, comparative analysis in the conventional and deep learning image fusion, among others. Dr. Rajesh Kumar has received several awards and honors, which includes Best LabVIEW Academy Award from the NIE in 2017, Best Paper Award from his research on the person follower robot system at the conference and in conference in 2024, Best Teacher Award from JNTU Kakinanda in the academic year of 2010 to 11. Dr. Rajesh Kumar has actively participated in various workshops, seminars, conferences, and training programs. Overall, Professor Rajesh Kumar stands distinguished academician, researcher contributing significantly to the field of VSLI. Then please welcome, I am inviting the distinguished speaker, Dr. Rajesh Kumar to address the participants. Please, sir, continue.
Yeah, thank you so much for your introduction, madam. Basically, a topic like this should be offline. Even then, I try to the best of my abilities to see that different aspects of robotic path planning and development of robotic system using different types of processors in this presentation. I would like to know whether my presentation is visible or not.
Visible, sir, visible.
Yeah, 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 yeah. I would like to know, first of all faculty participants are from mechanical engineering stream or from other different streams.
Sir, different
So
streams
all are,
participants are there.
uh,
All are
uh,
not mechanical, different streams participants are there. Computer science, mechanical, civil. So,
mm, okay, 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 okay. Yeah, it is a great opportunity for me, provided by the FDP coordinator for presenting one wonderful research concept, which is not that much popular in doing across the country. Suppose if you consider Moon rover and Mars rover, those all are developed using a special device called as field programmable gate array chip. Now, coming to the my presentation. So, before proceeding to the presentation, I would like to know whether I am audible or not. Am I audible?
yes, sir, audible.
Hello?
Audible, sir, audible.
Yeah, 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 yeah. Okay, okay. Thank you so much. So, my presentation will follow So in this presentation, what I would like to present, the first of all, how robotic exploration is going to be useful, what is the need of robotic exploration, and what are the key ideas for indoor exploration, and also how we implement exploration strategy, and then what is the importance of determining landmarks, and after that we see uh, different strategies for implementing the landmarks determination. After determining the landmarks, what is the need of short path finding? And another important aspect is, so far I guided 5 PhD students. In those 5 PhD students, two students, first two students of mine developed two different robotic systems. Those robotic systems are also going to be demonstrated through videos during this lecture. And also, one particular student of mine developed a snake robo, and two, three other PhD students developed different prototypes. My research went through so far with grants received from sponsored research agencies. The latest PhD awarded student also received UGC minor research grant. Through that, she developed ear biometric system. Those are all the different research works which I am carrying out, how I am pursuing my research ambition. I would like to illustrate. That's why I presented. Now, coming to the why do you need robotic exploration? See, for factory automation, suppose if you want to develop a robotic system for factory environment, if you want to develop a robotic system for canteen environment, so what are the challenges you are going to have? The first of all, suppose nowadays some of the households are having mopping robots. So mopping robots do not perform exploration. Do not perform exploration. And the audience is, please stop me whenever you have questions. You can like to have this as interactive, and this is having mechanical engineering component, computer science engineering component, and electronics related component. So coming back to the requirement of exploration, suppose if you take this diagram, in this diagram, this is the B, location B. At location B, what is happening? The item is coming down and going up is happening. That means between station 2 and station 3, one slab B is coming down, going up. Similarly, if you take another case, between station 1 and station 4, one slab A, wood slab, is moving, and that is cutting down. After cutting down, that is moving to the station 4. So These two zones are prohibited zones. Robotic system, when it is moving in the factory environment, it should not enter into those type of places. So for identifying those type of places, robotic exploration is required. Simply speaking, the robotic navigation can be done in two ways. One is with exploration, without exploration. Without exploration, some of us are seeing daily in our home, mopping robots. With exploration, robotic systems will exist in a dynamic environment case and semi-dynamic environment case. So, for dynamic environment case and semi-dynamic environment case, the robotic exploration is required to identify which places are having moving uh, obstacles and which places are static or no object occupied. So for that purpose, there is a need of robotic exploration. Suppose if you consider a room of size 4 meters by 4 meters, and if you assume 40 centimeters is the step size of the robo, that means grid point, between two grid points distance is for 40 centimeters, then we are going to have 100 grid points. See here, whatever I have shown are the grid points. These are the grid points. During the robotic exploration, the robo has to identify which grid point it can visit, which grid point it cannot visit, and which is permanently in the zone of prohibited for visit. So for that purpose, I developed one robotic system. And before going to that, I would like to explain what is the simplest way with minimal sensing. With minimal sensing, we can have exploration. So the proposed algorithm which I am going to demonstrate you is having usage of a robotic system with 8 ultrasonic sensors, and robo stops at grid point. So before moving to the next grid point, it will determine whether that grid point is occupied or not. And in the first phase, entire room is going to be explored. After that, it will determine what are the places it can visit. So assumptions made for implementing this exploration strategy are mentioned in this particular slide. And robo starts from a corner designated as origin, and it moves along east direction. That is the convention we applied. You can take any direction. So the robo moves in 4 directions only. We assumed in a inside room: east, west, north, south. That's all. So coming to the robotic system which we developed is having a PCA board, ultrasonic sensor array, and powered by a battery. That is shown snapshot in the Now, coming to the architecture, see, the architecture of the developed robo is having FPGA. Now, first of all, you have to know what is FPGA. FPGA is a field programmable gate array chip. We all know that microcontrollers. You know the the difference between microcontroller and FPGA. Anyone, please? Do you know difference between microcontroller and FPGA?
Sir, both are the controllers. They control the robot. APG also microcontroller and microcontroller.
No, sir. So I am going to show another slide where we will discuss about this particular. See here. So FPGA is a program. It is having digital logic elements called as lookup tables. FPGA will have pins uh, and it is having lookup tables. Lookup tables, LUTs, we call lookup table slices will be there, and block ROMs are also there inside the FPGA. So FPGA is reprogrammable device in which VLSI architectures can be implemented. That means uh, if you want to design a customized architecture, we all know microcontroller architecture, microprocessor architecture. Like that, for navigation also, we can develop one architecture. The architecture can be translated into the architecture can be translated into implementation on FPGA chip by using Verilog coding or VHDL coding. So FPGAs are one which can perform parallel tasks. Microcontroller executes tasks one by one. And the FPGA device can have built-in peripherals designed by us only. So FPGA is a unique IC which can be carried from one place to other place without attaching with the different peripherals, so that we can use. And also FPGA is one which is used for implementing the high-end computation related tasks, and parallel processing is possible in FPGA. So sir, have you followed this difference between FPGA and microcontroller? Hello? Hello?
Sir, got it.
Yeah. So for FPGA based design, we have to translate algorithm into VLSI architecture. Then that has to be coded using Verilog for the implementation using FPGA chip. So that is the task we accomplished in this research work. Yeah, now if you see this one, this FPGA board is one which implemented the exploration algorithm, and we are having motor control, So two stepper motors used for this particular robo. The robo is having two stepper motors. One free wheel is there, two back wheels are there. So, and 8 ultrasonic sensors got connected. Now coming to the exploration strategy. So the robo stops equally spaced grid points. And that already I mentioned to you. So this this architecture, this proposed architecture, key areas in the proposed architecture related algorithm. So this is a priority search algorithm implementing strategy, and it is having stack memory and content addressable memory also designed. Now, if you see this particular map, so here we are having, we have taken a room which is having equally spaced grid points. See, the robo starts at the corner. Initially, it moves like this. After reaching the wall, boundary wall, it will move to upward direction. Like that, it will complete the exploration of the entire room. So, to support the exploration of the entire room, we have used stack memory for storing the nodes visited, and content addressable memory, that is another memory. I think most of you know that we are having random access memory, read only memory, flash memory. So now in FPGA, we are having block ROMs. Those block ROMs we used for implementing the stack memory as well as content addressable memory. The content addressable memory stores a list of visited nodes. So if robo at one particular direction, say here, looks forward whether to know whether that node is visited or not. If visited, it is not going to visit once. Suppose if you take typical case here, see here, if after coming back to here, if robo checks whether in which direction it has to visit, then it will decide to visit in this direction. So in that way, robotic exploration will be done to identify grid points. Those are accessible. Accessible grid points will be identified by means of robotic exploration. That is the need of the exploration. Now, this is the complexity analysis related to this robotic exploration strategy. Say, so order of G, the overall complexity depends on number of grid points. Number of grid points. So this proposed algorithm explores depth first sight, number of visits to each node not more than 4. So these are the important points related to the proposed algorithm. So each ultrasonic sensor output, suppose if you take ultrasonic sensor, see, using ultrasonic sensor, we have to measure the distance to the obstacle. So for that purpose, what we have to do, after transmitting this ultrasonic signal, how much time it will take to get the echo signal. So the time lapse between transmitted signal, echo signal is measured. Based on that, distance to the nearest obstacle will be determined. So for that, we developed one particular VLSI architecture which will convert the pulse width to distance. Similar thing is getting implemented nowadays in microcontroller also. In microcontroller also, we have to convert pulse width to distance. And here we used the associative memory, content addressable memory, CCAM, is used to store visited and temporarily occupied nodes. And a stack is used to store the root nodes. Now, coming to the architecture of this robotic exploration completely, see here, now ultrasonic sensor are connected to the pulse width to distance converters. We developed pulse width to distance converters. And here, universal asynchronous transmitter. Universal asynchronous transmitter is connected to the motor driver to trigger its movement forward, left, turn, like that. To trigger that, we will send the signals through UAT. And this is the content addressable memory, which will store the list of nodes totally. And this is the stack memory. So I would like to know from audience, do you have any doubts so far in this discussion? Yes, please. Any doubts? Yeah. Moving forward, so we estimated the FPGA power consumption also. For estimating the power consumption, we have taken this particular environment. And the, see, here for 92 visits, when robo performed 92 visits, then the power consumption is 2.116 watts only, related to the power consumption of the processor. Now, if you compare this with the power consumption of Pioneer 3DX mobile robo, which is using laptop, the power consumption is like this. This is the total consumption of the Pioneer 3DX mobile robo. Now, I would like to show a small working of this robotic system also. 1 minute, please. So this is the small working model of the, see, this robotic system will find that two people are moving between those cardboards. Hence, it is not going to move either to the left or to the forward, either to the right or to the forward. See what is happening. See, now it is taken left turn. So, in that manner, that robotic system, in that manner, that particular robotic system, yeah, one minute, please. So, in that manner, that robotic system, whatever, whichever we developed, is moving for robotic exploration. Now, we will move to the need of landmarks. See, after exploration of the environment, we are going to get around 100 accessible grid points. Suppose if you take 4 meters by 4 meters, then step size as 40 centimeters, we are going to have 100 grid points. In those 50 grid points, uh, assume as accessible grid points. Now, construction of the map, that means for allowing robot to move from one grid point to the another grid point will result complex graph with many paths going from one end to another, and also for finding shortest path between any two nodes is going to be a challenging task. That's why we devised a strategy. In that strategy, we will determine landmarks. So suppose if a space is having 50 grid points to access, we will make 8 as landmark points. So based on landmark points, the robo will construct the graph of the environment. Then using the shortest path algorithm, the robo will move from one place to the another place. So that is the strategy we proposed and developed. So these are the some new terminology. One is grid points. So grid points are the inputs for the exploration phase. So whatever points robo is visiting, those are all called as grid points. So sample points. Sample points means accessible grid points are called as. So in the total bucket of grid points, we will have a portion of the grid points as accessible grid points. In those accessible grid points, we will filter out to make some grid points as the landmarks. So suppose if you are having 50 grid points, then construction of the map is very complex. That's why we reduce them into the landmarks. So from landmarks, we will devise the strategy for visiting this, visiting from one place to the another place. So these are the key ideas related to the landmarks. See, from accessible grid points to the landmarks, from accessible grid points to the landmarks, we are having, from accessible grid points to the landmarks, we have to follow a strategy. So for that strategy, I used machine learning method by using the self-organizing map, that is called as SOM popularly in neural networks. So this self-organizing map is one which is going to be trained. After training, this will results the landmarks. So see, these are the randomly distributed points. So in these star marks, we train them, we will make them landmarks. If you make them landmarks, then it is very easy to construct the map of the environment. So after constructing the map of the environment, then we used the shortest path algorithm to find shortest path between any 2 points. Based on that, robo moves from one point to the another point in the indoor environment. So this is the totally indoor robotic system exploration strategy. So here I already explained to all of you that robotic navigation can be implemented either using exploration or without exploration. So the exploration strategy is required where dynamic, semi-dynamic objects are prevailing. And for after exploration, we will find what are the accessible points. From the accessible points, we will determine the landmarks. After determining the landmarks, we construct the map of the environment. After constructing the map of the environment, we will make sure that the robotic system will implement shortest path algorithm to move from one place to the another place as per given specification. In that way, we designed and implemented the first robotic system. Any doubts so far? Hello, any doubts so far? So far, any doubts?
No, sir. No, sir. You can proceed, sir. No, sir.
Yeah. Yeah. Coming to the other important aspect, that is the development of canteen robo. Just 1 minute. So the second robotic system which we developed, is the slide is visible, sir?
Yes,
Slide
sir,
is
visible. Visible,
yes.
sir.
Visible, sir. Visible.
Yeah. So the second robotic system which we developed was canteen robo. and we got patent also. We got some orders from Hyderabad based hotels also. My PhD student making robotic systems to supply that. So this is the typical canteen environment which we considered. See, in canteen environment, we assumed that two cubicles are existing. And the developed robotic system will be provided to which table it has to go and stop. So, in any robotic system development for indoor environment, the first challenge is how do you provide the localization information? That means how do you provide table 1 is at one place and chair 1 is at that place, and table 2 is at which place, like that. How we will provide in the early stages, we used barcodes for providing the location information, grid points information. In this canteen environment system, we used RFIDs. We use, some noise is coming. Yes, please stop. Please mute. Hello? Yeah. Thank you. So, this is the typical canteen environment which we considered. And uh, we are going to provide data of uh, different tables where this robo on its way has to stop. So we assume that initially the robo is at main point where items are getting done, and those items are placed on the robotic system top platform. We will have a one uh, empty platform, empty plate type thing at the top of the robo. On that plate, big plate, square plate, items will be placed, and the robo is programmed in the beginning at the center point through communication. It will be provided data that table 1, chair 1, table 4, so cubicle 1, table 1, chair 1, like that will be provided. And entire localization related to cubicles, tables, and chairs have been done with the help of RFID. So we assume that this is a semi-structured canteen environment, and we developed this robotic system in-house only. In the college only, we developed this robotic system. See, here, this particular site presents that how localization has been implemented. We assume C number of cubicles, T number of tables, S number of seats. And using Zigbee communication, food items to be served will be informed. So after giving these all informations, so it has to sort out using the merge sort algorithm. So destinations in an ascending order will be arranged from the start location, origin location. And using the minimum spanning tree, the intended destinations will be identified. So, like that, we have developed the strategy and we implemented that strategy in a developed environment at our campus. Now, I will show the working of such a system. Is it visible? So this is the canteen robo. We developed 2 canteen robots, and this is the environment we created in our lab at that time. And the robotic system is moving from one cubicle to another cubicle. See, traversing from one cubicle to another cubicle successfully using the RFID localization information.
Sir,
Without
slide is not visible, sir.
Not
Slide is not
visible.
visible. No, sir.
Just 1 minute. Now visible, sir?
Yes, sir, it is visible now. Now it is visible.
Yeah. So this is we actually developed 2 robotic system, as I mentioned previously. This is the robotic system, single robo in this environment. This entire environment we created at our lab space by removing all the lab tables, work tables, so on, so on. It is a very hard work carried by my first PhD student. And see how this is moving successfully from one room to one cubicle to another cubicle. Okay, I will show another one interesting thing. Here we are having 2 robotic systems. How they are moving. So this robotic system is controlled by FPGA only. Controlled and guided by FPGA by means of sensors data. We used minimal sensing, sir. Here we have not used any camera also. For localization, RFIDs. And these 2 robots won't touch each other also. See. So to identify whether other robo is coming in front of first robo or not. For that also, we attached RFID as the information provider. Each robo is having one particular RFID. By sensing that RFID, the robo will know whether other robo is there or not. So, like that, these algorithms got implemented, and I would like to show one more video clip related to this particular robotic system. one more thing, similar thing, I think. This is also same. See clearly. Yeah. Next, coming to the next research work related to the robotic system development. So I received RPS grant. Using that, we developed a person follower robotic system. So for this purpose, we have used NISB Rio robotic platform. It is for to verify when a old age person making small exercise or making rounds in a room, then his status is good or he is in the falling state. So whether a person is about to fall or not, when he is when voltage person is moving or walking at a particular location. For that purpose, we developed this particular person follower robotic system. So this person follower robotic system implements neuro fuzzy logic based algorithm. So first of all, we used optical character recognition. Is the slide is visible or not? Hello? Hello?
Yes, sir. Visible, sir. Visible, sir.
Yeah. See, this is the person following system which we developed. The SBRAO based robotic system is there, that is fitted with IP camera. Wireless router is also there. So the FPGA board is having this SBRAO system is having FPGA board and also microcontroller board. Microcontroller is meant for controlling the motors, and FPGA is meant for implementing the algorithm. And the IP camera is interfaced with the FPGA board. See. So this is the SBRAO platform inside structure. It is having Spartan 3 FPGA and PowerPC processor. So here the robotic system moves forward, left, right, and that is going to use the neuro fuzzy logic based algorithm for controlling the movement of wheels. Related to this, I would like to show one video clip uh, for showcasing its working. See, this is the robotic system we developed and conducted experiment in our lab. If F is there, F letter is appearing, by recognizing the F character, the robotic system will move forward. When L appears, it will move leftward direction. So it will continuously follow the person. Left, forward, right, in those directions, the robot will follow the person. If person is about to fall, then it will inform to the person who is supervisor for this particular old age people. So in this way, this robotic system. So the main intention is in hospital, after having bypass surgery or angiography, patients requested to move in a particular place. At that time, with a single person at remote to see whether each one is moving properly or about to fall, to detect that one, this particular robotic system was developed. That is the intention of developing this particular robotic system. So these are all the different robotic systems. Those have been developed over the time. At this point, I would like to take questions from the participants, please. Hello? Any question?
Yes, sir. One question is there.
Yeah, please.
Actually, I want to know what is the cost required price investment is in for the developing that robot, canteen robot.
Canteen robot, around 25,000 we spent, sir, for platform development. For platform development, we spent 25,000. Then through grants, we purchased FPGA board, other sensors, so on. We fitted. So totally with 50,000 rupees cost, we can develop prototype. But when you go for mass production, further cost reduction can be achieved, and also we can augment that particular design with camera, and also using convolution. See, this canteen robo is not humanoid. We can translate this basic research into humanoid robotic system, which can be used in the canteen environment, where people will feel happy about getting things from the robo. That is one thing. For a high-end robo, for high-end hotels, we can do that one. So when we approached the low-end self-service canteens model setup, there we got objection. If you place robotic systems here, it is going to kill the employees' opportunity. So that's why we have not received grant for developing a robo which can be used for self-service. But one NGO came forward initially. After that, they got remark like that. Then they are not provided. So that is the story about this particular canteen robotic system.
Sir, this is not for a robot, canteen robot system. Everywhere, if technology advancement is there, means definitely there is no requirement of employee. So in this case also you can use, na? Because
see, high-end hotel will prefer, sir. High-end hotel will prefer. Suppose if you take small self-service hotel, in self-service hotel also we can place this particular robotic system. So at that time, that particular NGO who came forward for supporting commercialization of our robo told for self-service canteens we won't support. We got remark like that. See, in India, people are more. In India, robotic systems are not required for canteen service.
yes, sir, yes, sir.
See, we have to see the demography of our country also, na?
Yes, yes, yes. That's true, sir.
Yeah.
Okay, thank you, sir.
Thank you. Any other question? Yeah, please, madam.
Thank you, sir. No, actually, I'm the co-coordinator of the FDP
Okay.
this session. Yes, sir. I'm just waiting for any questions from participants. Well, I think there is no more questions. Dr. Ranjan. Okay. Okay, thank you, sir, for this interesting topic sharing with us. And I hope our participants will definitely get benefit out of it in their research. And if they wish, in future, they will contact you. Your contact mail ID and all details are available in his website. Thank you so much. Since our next session will be started at 7:30 as per the schedule, so we can have a break of 20 minutes, around 20 minutes now. So meeting will be resumed at 7:30 again. Thank you, participants, and requested to join at 7:30 again. Thank you.
Okay, thank you, madam.
Thank you, sir.